Hello students, welcome you to this session. We are studying set, relations and functions. Already we studied sets and relations. What is relation? Subset of Cartesian product, right? And today we are going to see what is function. Already you would have studied in 10th standard, right? So a relation is a function under some condition. Every relation we cannot take it as a function, right? So there is a domain, codomain. Every element of the domain must have image. Every element of the domain must be related to some element in the second set, that is codomain. And every element must have only one image. So to which element it is related, that is called image, right? So every element of the domain must have image and it must have only one image. Suppose if we see a number has two images, then both must be same. So every element must have only one image. That we call it as what? Function. So we are going to see what is function, what are the different types of functions, how to find domain, how to find range, composition of functions, inverse of a function. All these things we are going to study in this class. Okay. So now let us see what is the definition of function. So they can ask any question. So define function. So you have to write this. Okay. So let A and B be two sets. A and B be two sets. A relation from F from A to B. F is a relation from A to B. It is a relation. That means it is a subset of A cross B, right? Is called a function if it satisfies two conditions. What is the first condition? You see, for all A belongs to A is a set, right? For every element A from A, there is an element B in the set B. Every element in A, you can find an element in B so that A is related to B. A is related to B under the relation what? F. Okay, so A comma B. So that image of A is what? B. Every element of the domain must have image. Okay, and the second condition you see, if A comma B and A comma C, A comma B belongs to F, that is A is related to B under the function F. A comma C belongs to F, that is A is related to C under the function what? F. A is related to B and C, then B must be equal to C. Both must be same. That means one element cannot have two different images. Okay. So very simply, if you want to say every element of the domain must have only one image, then we say it is a function. Now listen, there is a test called vertical line test, or simply we call it as vertical test. So what is vertical line test? You know, there are two things you have to remember here. One, what is the purpose? So vertical line test is used for what? If a graph is given, if a curve is given, you can check whether it represents a function or not. So that is the use of this vertical line test, to check the given curve represent a function or not. And the second point you remember, how to check. You draw vertical line. You draw vertical line in the domain. You cannot draw somewhere as you like. When you draw a vertical line, it cuts the curve at only one point. It cuts the curve at only one point, then you say it is not a, then you say it is a function. If the curve cuts at only one point, it is a function. Suppose it cuts at more than one point, or it is not cutting at all, then you say it is not a function. Okay, listen, testing whether a given curve represents a function or not by drawing vertical lines is called vertical line test, or simply vertical test. So that is the purpose of the test. Then how to test? If the vertical line through a point X in the domain meets a curve at more than one point or does not meet, then it will not represent a function. So it represents a function only if it cuts at only one point. Okay, so that is vertical line test. Then some different type of functions. I'm not going to take everything, you know, reciprocal function, modulus function, everything. So some of the important functions, greatest integer function, greatest integer function. So greatest integer function, see, this is the symbol, or we call it as floor function. Greatest integer function, the symbol, see, it is like this, like close bracket, but top it is not there. Okay, so This you read it as greatest integer function of x. How to find that? Listen carefully. Suppose you take a number line. For objective questions it is important. So this is a number line. I'm taking the points. We take say 0, 1, 2, 3, etc. minus 1, minus 2, minus 3, etc. I want to find the greatest integer of say 2.3. What you have to do, no? You plot that point 2.3, that is between 2 and 3, right? 2.3 is here, 2.3. It's left side integer. In the right side, 3 is there. In the left side, which integer is there? 2. So the answer is what? 2. You plot the point, take the left side integer. Suppose my question is, say, minus 2.5. Greatest integer of minus 2.5. Where is minus 2.5? Minus 2, minus 3, in between, minus 2.5. So greatest integer function means left side integer. What's the left side integer? Minus 3. The answer is what? Minus 3. Suppose the question is greatest integer of 2. 2 itself is the integer, right? So the answer is 2 itself. Okay, so greatest integer function, to find, very simple method. Left side, greatest integer function, you take the left side, then the another one we are going to study. Okay, least integer function, you take the right side. So don't confuse with these two, and easily you can remember. See, greatest integer function, how we are writing the symbol? This symbol, right? It looks like what? L. L for left side. Okay, so you won't forget. So greatest integer function, this is the symbol, right? So it looks like L. So you take the left side element. So this is just a hint for you. Suppose I want 0.5, greatest integer of 0.5. So 0.5 lies between 0 and 1, right? So 0.5 is here. So the left side number integer. What's left side integer? 0. Okay, like that you can take. So for every element, you take the greatest integer. Say, drawn a number line, x-axis, y-axis, x dash, y dash. I mark that. 0, what's the greatest integer? 0 only. 0.1, left side integer 0, right? 0.5, it is 0. 0.9, it is 0. So everything lies in that line itself. But for 1, it is 1. So this 1 is not included. If you circle it, the point is not included. If you shade that, that point is included. Okay, that and I'll take you a little later, all these things. Then for 1, it is 1. 1.5, it is 1. Because 1.5, 1, 2, 1.5 is here, the left side integer, the answer is 1. Up to 1.999, it is 1. Only for 2, it is 2, right? So for 2, it is 2. Then up to 2.9, it is the same number, okay, 2 only. Then for 3, it is 3. Then 3.1, 3 point, everything, it is what? 3 only, okay? It goes like the same way the left side also. So if you see the curve, it looks like a step, right? So we call it a step function. We call it as what? Step function. So this is greatest integer function. So how to denote greatest integer function? And how to find? Easy method I said. Plot the point in the number line. Take the left side integer. Then how to draw the graph. So practice this graph also. Okay. So now let us go for smallest integer function, or we call it a seal function. How to denote? Greatest integer function, we denote it like this, right? So here just upside down like this. And how to find greatest integer function? We have taken the left side. So here you take the right side element. You take the right side element. Okay, so we take a number line. Say this is a number line. I'm taking some elements. Say 0, 1, 2, 3, 4, and here minus 1, minus 2, minus 3, etc. I want the smallest integer, right? Smallest integer. So smallest integer, this is a symbol. Smallest integer function of integer of 1.3. So what do you do? You plot 1.3. Where is 1.3? Between 1 and 2, right? 1.3. For greatest integer, we go to take the left side integer. It is 1. But here, smallest integer function, you take the right side value. What's the right side value? 2. So the answer is what? 2. Suppose the smallest integer of minus 1.3. So check where is minus 1.3 between minus 1 and minus 2, right? Minus 1.3. So it's right side value. What's the right side value? Minus 1. So here also smallest integer function of 3, integer of 3 is 3 itself, because 3 itself is an integer. Okay, don't go for right or left, that integer itself. Okay, so here also if you plot the point, okay, so here 0, it is 0 only. 0.1, 0, here 1, right? After 0, 0.1, we take the right side integer. The answer is what? 1. So that is why for after 0, for everything, the answer is what? 1. So that is why it is here. In 1 we have. Then when it is, for 1 also it is 1 only. Then 1.1, when it comes, the right of 1, 1.1, everything up to 1.999, the right side value it is 2. So after 1 for all these, the answer is what? 2. Okay, this is 2. Then for 2 also it is 2. Then 2.0001, once it crosses 2, the answer is 3. Because after 3, after 2, any point very close to 2, 2.001, once it just crosses 2, the right side integer. What's the right side integer? 3. Okay. So after 2, for everything it is what? 3. Up to 3 it is 3. Okay. Once it crosses 3, it is 4, the right side integer. Okay. Same way in the left side also. Okay. So practice this diagram also. So smallest integer function, the another name also you remember, ceil function. How we denote it, how to find the value. Plot the point, take the right side value and see the graph also. These are two-step function. Here also diagram resembles the previous one, right? Types of function, I'm not going to take much. Already you are thorough with this, I think. So what are the different types of function? Already you studied one function, many-one function, onto function, into function, right? Then bijective, right? Then constant function, identity function. What is identity function? Every element related to itself. 1 is related to 1, 2 is related to 2. I of x equal to x. F of x equal to x. Okay. So that is called identity function. Constant function, every element related to a constant. F of x equal to 5. You give any value for x, your answer is 5 only. So that is called constant function, right? Okay, listen. Here one function given. First you check, is it a function? Domain, A is the domain. The first diagram you see. A is the domain, B is the codomain. Every element of A. What are the elements of A? A, B, C. Every element has image, right? So first condition satisfied. Every element of the domain must have image, and it must have only one image. A, the image is X. B, image is Y. C, image is Y. Two elements can have the same image, no problem. But one element should not have two images, two different images. Okay. So when it is arrow diagram, it's very simple. From every element, one arrow starts, right? That's all. Here, A, one arrow, B, one arrow, C, one arrow. It is a function. Now, suppose if there is one more element here, D is there. It is not a function. What reason you say? The element D has no image. So it is not a function. Suppose the C is related to Z. We say it is not a function. Why? The element C has two images. It is not a function. So here it is a function only. What is domain? A, B, C. What is the first one? Domain is A, B, C. What is codomain? Second set fully you take X, Y, Z. What is range? Only that related elements. What are the elements? X and Y. Okay, so domain, always range is the subset of what? Codomain. In some cases, codomain and range are same in onto function. Okay, in onto function, we'll see that. So this is, it is one or many one? It is many one, because many elements are related to one element. Many elements are related to one element. So it is a many one function. Many one function. It is it is many one function. It is onto or into? You have to see the codomain. In the codomain, if every element has pre-image, see, X has pre-image. What is the pre-image of X? A. What is the pre-image of Y? A and B. What is the pre-image of Z? There is no pre-image. Then it is into function. It is not onto. It is not onto. See the last one? One or many one? It is many one, because many elements are related to one element. One, many one, there won't be any problem, right? It is onto or into? Domain, codomain you see, codomain is B. Every element of codomain have preimage, right? X, it has preimage, Y also have preimage. So every element have preimage. So no element left out, okay? So that function we call it as what? Onto function. If you are not thorough, sir, and onto I'm not able to identify, it's a little easy method to remember. You see the second set. You see the second set. How many elements left out? Don't say no. How many? You should say the number. How many elements left out? 0 element. Then it is which function? Onto function. I think hereafter you won't forget. 1, 1, many one you can find very easily. Onto, into, you see the second set, that is codomain. Any element left out, you check. If there is no element left out, that is 0 element left out. 0 you write first. Onto function. If some element left out, it is not onto. If it is not onto, it is what? Into function. In the first diagram, some element left out. Is that left out? So it is not onto, it is into. Now the second one you can say very easily. Second diagram, it is 1, 1 or many one? 1, 1. It is 1, 1 function. Onto or into? It is not onto. Some element left out, right? So it is not onto. That means it is what? Into function. Hope you understood this. 1, 1 function, another name you remember, injective function. Onto function, another name is surjective function. 1, 1 and onto, if both are satisfied, we call it as bijective function. If a function is 1, 1 and onto, we call it as what? Bijective function. Listen. Then we are going to see inverse of a function. Inverse of a function. F is a function from x to y. F is a function from x to y. Its inverse is a function from y to x, right? Inverse function. F is from x to y. F inverse is from what? Y to x. And we take it as g. G is the function from y to x. Y to x. Here f of x equal to y, right? F of x equal to y. Here g of y is equal to x. So this is the inverse of that function. And inverse of the function we denote, here the inverse of the function is g. So, and we denote it as what? F inverse, okay? So, F is a bijection. Only for bijection we have inverse. F is 1, 1 and onto, then only it will have what? Inverse. F from x to y is an bijection. That is, it is 1, 1 and onto. The function g from y to x, defined by g of y equal to x, is called inverse of f. F is f of x equal to y, okay? And it is denoted by F inverse. If a function f has inverse, then we say it is invertible. F is invertible. If you see the term somewhere, that means it has inverse. Okay, it has inverse means it is a bijection. Okay, it is 1, 1 and onto. All these things related terms only. Prove that it is invertible. Prove that it is a bijection. Both are same only. Okay, so invertible means it has inverse. Only if the function is a bijection, it has inverse. A function f from x to y is said to be invertible if there exists a function g from y to x. F is a function from x to y and g is a function from y to x. Such that this is another way how to prove. When you do the sums, we are going to use this, okay? G composition f of x, when you find, you will get the identity of x. Identity of x means it is x. Also, f composition g of y equal to identity of y. That is, your answer will be y. You would have studied in matrix and all. How can you prove the two matrices? A is a matrix and B is another matrix. Prove that they are inverses to each other. How can you prove? You find AB. Also you find BA. In both the cases, you would have got the identity matrix, right? 1, 0, 0, 0, 1, 0, 0, 0, 1. Then we say they are inverses. Same way, F and G are inverses. When you find the composition, that is one of the operation in composition. In numbers, you have addition, subtraction, multiplication and all. No? Same way for function, you have composition. 10th standard you study, anyhow I will teach that also. So when you find the composition, F composition G and G composition F, you have to get the identity element. Okay, identity on X, it is X, small x, and identity on the set Y is what? Small y. So this is very important. This is how we are going to prove that. Okay, next test is called horizontal line test. Already we studied vertical line test. I said to remember two things. One is the purpose for what we are using. Vertical line test for what we are using? To check whether the curve is a function or not. And how to check? You draw vertical line. If it cuts at only one point, it is a function. If not means it cuts more than one place or it does not cut in the domain. Then we say it is not a function. That is to check whether it's a function or not. But horizontal line test, first the purpose. A function is given. There you check whether it is a function or not. But here a function is given. We have to check whether it is 1, 1 onto or not. So a function is given. So we are going to check whether it is 1, 1 or not. Okay, for that is the purpose of horizontal line. Here we draw horizontal lines. So there we draw vertical line. But here we draw horizontal line. 3 steps you remember, just to explain to you. See the first one. So this is a given curve. This is a given curve. So in the codomain you draw horizontal line. This is the codomain. Okay, so in the codomain you draw horizontal line in the given codomain. Don't draw somewhere and you say, sorry, not cutting. No, in the given codomain, in the range only, in that part only, you have to draw horizontal line. So it does not meet. That means it is not onto. Meaning some of the elements have no pre-image. Some of the elements in the codomain have no pre-image. Few elements have pre-images and few elements have no pre-image. So, okay. So when you draw horizontal line, it is not cutting the curve at all. Then we say it is not onto. The meaning, some of the elements of the codomain have no pre-image. So that means it is not onto, it is into. Okay, that is one case. Another case, if it cuts at only one point. If it cuts at only one point, you say it is 1, 1 function. If the horizontal line cuts the curve at only one point, exactly one point, then it is 1 to 1. So every element, there is only one image, right? So it is 1, 1. Suppose the horizontal line cuts more than one point. See, listen. Here the horizontal line cuts more than one point. So what's the meaning of this, For this point, the image is this one. And for this point also, image is the same. For this point also, the image is the same. So for more elements have the same image. For more elements, they have the same image. Then it is not 1, 1. It is what? Many 1. It is not 1 to 1. Okay. If the horizontal line through at least one point meets the curve at more than one point. So when you draw a horizontal line through one point, at least one point cuts the curve at more than one point. Okay. Then we say it is not 1 to 1. That means it is what? Many 1. Okay, so these are some of the very important results. And now the third exercise we have to start. Hope you are thorough with first exercise and second exercise. Third exercise, normally students find difficult. I'll tell you the reason why. You need a lot of results. The results what you studied already means okay. That just you can recall. Not only that, you need some of the result what you have not even heard about. You would have not studied so far. That also you need. That is the problem. So I'm not going to start the exercise directly. I'm going to teach some of the results what you need. After that we go for the exercise. You'll find it very, very easy and it will be comfortable for you. Okay. So let me teach some of the results, and everything is in our syllabus. We are going to study in detail in the following chapters. Okay. But since it's the first chapter, so you need more help. Trigonometric equation. So trigonometry itself is allergy for many students, right? A lot of formula, right? So here also you have one chapter fully trigonometry. So you cannot escape from trigonometry. Without knowing trigonometry is very, very difficult. Even differentiation, integration, everything you need. It's very easy chapter, but only thing, learn systematically. Learn from the basics of trigonometry. Suppose if you are not thorough with the basics, or I don't know what is even the trigonometry identity and all. So we have uploaded a separate video for the trigonometry basics. So you can go through that. Listen, trigonometric equation. You know what is equation? equal sign is there. Trigonometric equation means some trigonometric ratios will be there. 2 sin x plus cos x equal to 5. It is a trigonometric equation. Okay. So trigonometric equation has solutions, and we are going to study this in detail later. And now I'm going to give some formula. Please take it as a formula. Don't ask me how and all now. Okay. See, I'm going to give two sets of formula. The first one, sin theta 0. One answer you know. Sin theta equals 0 means if I ask what is theta, you will say immediately. Sin which angle is 0? Sin 0 is 0. You will say yes sir, theta is equal to 0. This is not the only one answer. Trigonometry functions has infinitely many solutions. Why you know? See, this is 0. From here if you move like this is 90, right? Then 180, 270, 360. 360 is also equivalent to what? 0 only. So 0 or 360, all these are same. No? If you go one more round, 720, that is also same. So if I take 30 degree, if this is 30, 360 plus 30, 390 also same only, right? This is for you to easily to understand. There are many solutions, right? Not like algebra. Suppose a linear equation means it has only one solution. Quadratic equation has two solutions, right? And so on. But trigonometric equation has infinite number of solutions. The basic solution, what you know, that is called principal solution. That also there is some condition. We will study in that chapter in detail. The value which lies in the principal range we say. So here, you know, suppose if I say sin theta is equal to 1 by 2, you know, sin which angle is 1 by 2? Sin which angle is 1 by 2? 30 degree, right? 30 degree. That 30, pi by 6, pi means 180. Pi by 6, that is one of the solution. There are many solutions, infinite number of solutions are there. This is one solution. And this solution has a special name, we call it as principal solution. This solution we call it as principal solution, and the principal solution normally we denote it as what? Alpha. Okay, so with this idea, now please listen here. Three results you have to study from the first set. Sin theta equals 0, these are the equations. Sin theta equals 0, cos theta equals 0, tan theta equals 0, then what is theta? Sin theta equal to 0, then theta is equal to n pi. Theta equal to n pi. Cos theta equals 0, theta equal to 2n plus 1 pi by 2. Tan theta equals 0, theta equal to n pi. And what is n? N is an integer. N is an integer. You know what is integer? 0, 1, 2, 3, etc. Minus 1, minus 2, minus 3, etc. So in the first answer, theta equal to n pi. For n you put the value 0. If you put 0 into pi, 0, right? That's what one answer you got. Sin theta 0 means theta equals 0, right? When you put 1 into pi, it is pi. That's also a solution. You put 2, 2 pi, 3, 3 pi, etc. Minus 1, minus 1 into pi, minus pi. Minus 2, minus 2 pi, minus 3 pi. All these are solutions. How many solutions? Infinite number of solutions are there. Okay. Same way, cos theta equals 0. This formula you study. Theta equal to 2n plus 1 pi by 2. Tan theta 0, theta equal to n pi. All these formula you can use only when the right side equal to 0. The right side value is equal to what? 0. Sin theta is equal to what? 0. Cos theta is equal to 0. The right side values are zeros. If the right side values are not 0, for example, here I said no. I said in one example, sin theta is equal to what? 1 by 2, right? Sin theta is equal to 1 by 2 like this. Sin theta equal to 1 by 2. That is sin theta is equal to 1 by 2 can be written as sin pi by 6. Now this is of the type sin theta equal to sin alpha type, right? So that is the second set. So this is the second set of results you have to study. Sin theta equal to sin alpha, cos theta equal to cos alpha, tan theta equal to tan alpha. The previous one, the right side values are zeros, but here they are not zeros. Some numbers that can be written like this. So sin theta equal to sin alpha, then entirely different formula. There the formula is only n pi, right? But here n pi plus minus 1 raised to n into alpha. Cos theta equal to cos alpha, theta equal to 2n pi plus or minus alpha. Tan theta equal to tan alpha, theta equal to n pi plus alpha. So these are the formula. Please learn this. So when to use the first set? If the right side value is 0, when the right side values are not 0, you have to use the second set. Okay, these formula you study so that when you go for trigonometry, it will be easy for you. Where n belongs to z, like what I said earlier, and alpha already said it is the principal value. This is one set of results you need. Then this one you remember, sin theta, the maximum value is what? If you see the table 0, 30, 45, 60, 90. So it is what? Maximum value is 1. Minimum value in that table, it looks like 0, but it goes up to -1. Okay, so that also we'll study later. Sine theta and cos theta always lies between -1 and +1. The minimum value -1, maximum value 1. It cannot exceed 1. Also, it cannot take any value lesser than -1. Okay, so sine theta and cos theta always lies between -1 and +1. Tan theta, if you take, it goes up to infinity, because you know tan 90 is what? Infinity, and in the left side it goes up to -infinity also. So tan theta takes any value, -infinity to +infinity. Only sine and cos takes values only from what? -1 to +1. That one you remember. Another very important thing, inequality. Listen, you know 2 is less than 4, right? 2 is less than 4. Suppose I'm adding 5 with both sides. Both the sides I'm adding 5. So 5 plus 2, 7. Here I add 5, 9. What sign you have to put here? Less than or greater than? 7 is less than 9 only. Okay. Suppose I'm subtracting 1. Subtracting 1, you will get 1 and 3. What sign you put? 1 is less than 3. I am multiplying 5. If I multiply both sides by 5, 5 2s are 10. 5 4s are 20. Again less than, right? If I divide by 2, left side become 1, right side become 2, 1 is less than. So the inequality remains same, right? Here the sign is less than. Here also everywhere it is less than only. So what we did? You can add same number on both sides. You can subtract same number on both sides. You can multiply, right? You divide. And it reverses in 2 cases. Okay, the inequality reverses in 2 cases. When you multiply by a negative number, here I multiply by a positive number, right? If I multiply by a negative number, for example, I am multiplying by -1. See what happens? -2, -4. In the number line, you see 0, -1, -2, -3. When you move to the left side, the values are decreasing. So -2 and -4, which is greater? -2 is greater. So see, the inequality reverses. Less than become greater. When you multiply or divide by a negative number. So this one case, the inequality reverses. When you multiply or divide by a negative number, the inequality reverses. Reverses means less than become greater, greater than become lesser. This is one case. And in one more case, the inequality reverses. You take reciprocal. 2 reciprocal is 1 by 2. 4 reciprocal is 1 by 4. Half, quarter. Half is greater, right? Half is greater than quarter. Here also you see the inequality reverses. Less than become now greater. In these 2 cases, the inequality reverses. Okay, so which 2 cases? When you multiply or divide by a negative number, the inequality reverses. And one more case, when you take reciprocal also, the inequality reverses. Now listen. Solution of quadratic equation, you know. Suppose a quadratic equation is given. If I ask you to solve, you will solve immediately, right? How many answers you will get? You will get 2 answers. Quadratic equation, if you solve, you will get 2 answers. You studied so many methods. Factorization method, completing the square method, right? Formula method. You are remembering what's the formula? -b plus or minus root of b square minus 4ac by 2a. But now I'm going to teach you how to solve quadratic inequality. So this is another very important thing. Listen. So it has many solutions. Quadratic equation has just 2 solutions, right? But quadratic inequation has infinite number of solutions. So please listen here. So I'm giving in the factorized form. X minus alpha into x minus beta less than 0. So suppose it is equal to 0, you know the answer immediately, right? If it is equal to 0, what's your answer? X is equal to alpha. You take the first factor equal to 0 or second factor 0. That is x minus alpha 0 or x minus beta 0. You will say x is equal to alpha and beta are the solutions if it is equation. If it is inequation, remember, if the sign is less than, you say lies inside. So the solution, what you say, not same alpha and beta only we are going to use, but if the sign is less than, you say it lies inside. X lies inside alpha and beta. Lies inside alpha and beta. Assume alpha is smaller than beta. Okay. So lies inside or lies between. Okay, lies inside. See, listen, suppose in the number lines, here it is minus infinity, here it is what? Plus infinity. And I'm taking, say, this is alpha and this point is beta. Lies between alpha and beta means this is the portion you have to take. You can shade in a graph, okay, in a number line. You can write it as an inequality also. How can you write, alpha less than x less than beta. X takes values between alpha and beta. So remember, when less than comes, you say lies inside, greater than means lies outside. So easily you can remember, less than, inside, greater than, outside. Okay. Then less than or equal to, see the next one. Less than or equal to, already said, less than means inside, right? So I'm marking alpha and beta. Less than means inside, but less than or equal to is here, no? Less than or equal to, so that point is also included. The previous one, that alpha and beta are not included, but here alpha and beta are also included along with the points inside. So how can you write it as an inequality? Alpha less than or equal to x less than or equal to beta. Are you able to understand? Less than means inside. N points are not taken. But less than or equal to means inside only, but that boundary points, the end points are also included. Okay, so less than, inside. Greater than, outside. See the next one. X minus alpha into x minus beta greater than 0. So what can you say? X lies outside alpha and beta. X lies outside alpha and beta. Please listen. This is minus infinity plus infinity. I'm taking this is alpha, this is beta. Don't take anything inside. Outside alpha and beta. Don't take inside. So don't take this portion. Okay, you have to take outside. Outside means this portion and this portion. So how can you write it as inequality? Minus infinity to alpha and what? Beta to infinity. So you can write it as interval also. How you know? Minus infinity, comma, alpha. Don't confuse with alpha and infinity. Okay, so minus infinity to alpha and union beta to infinity. Beta to infinity. Okay, the first portion, that is minus infinity to alpha. Union also we have which portion? Beta to infinity. Okay. So or you can say x is less than alpha and x is greater than beta. X is less than alpha means alpha's left side. Greater than beta, beta's right side. This is like you can write using inequality also. So you can write the answer in different ways. Okay, you can shade in a number line. You can give it as inequality. You can write it as a set. So greater means outside. Next one, greater than or equal to. Same thing, but that point is also included, right? So minus infinity to plus infinity. We are taking 2 points, alpha and beta. Greater than means outside. But greater than or equal to, so that alpha and beta also to be included. So how to shade this, how to write it as a set? Minus infinity to alpha. Alpha is included, closed interval. Minus infinity or plus infinity, always you have to use open interval. Because closed interval means that point is included. How can you include infinity? We don't know what is infinity. It's a very big number, that's all. Minus infinity, very small number. We don't know what it is. You cannot include it. So whenever you write plus infinity or minus infinity, you have to use only open bracket. Okay, don't use closed bracket. So minus infinity to alpha. Here alpha is included. Union. The second one, beta is included. So closed interval beta. Beta, comma, infinity. Infinity, you have to use only open interval. Okay, so hope you understood this. So these are some of the basic things. So today I didn't teach any sum, right? But if you are thorough with the results and all the facts, and I think definitely can do the sums very easily, and you need more help. So in my next video, I will teach sums based on that. But before that, prepare all these things and get ready. See you in the next video.